What is a transistor? A transistor is a miniature semiconductor that regulates or controls current or voltage flow in addition to amplifying and generating these electrical signals and acting as a switch or gate for them. Typically, transistors consist of 3 layers, or terminals, of a semiconductor material, each of which can carry a current. Transistors are crucial components of modern electronics. When working as an amplifier, a transistor transforms a small input current into a bigger output current. As a switch, it can be in one of 2 distinct states, on or off, to control the flow of electronic signals through an electrical circuit or electronic device. Why transistors are important? A transistor has only one circuit element. In small quantities, transistors are used to create simple electronic switches. They're the basic elements in integrated circuits, ICs, which consist of a large number of transistors interconnected with circuitry and baked into a single silicon microchip. In large numbers, transistors are used to create microprocessors where millions of transistors are embedded into a single IC. They also drive computer memory chips and memory storage devices for MP3 players, smartphones, cameras, and electronic games. Transistors are embedded in nearly all ICs, which are part of every electronic device. Transistors are also used for low-frequency, high-power applications, such as power supply inverters, that convert alternating current into direct current. Additionally, high-frequency applications use transistors, such as the oscillator circuits that generate radio signals. List of some of the benefits of transistors. Transistors have many benefits, from amplifying signals to requiring low voltage supplies to being highly suitable for low power applications. How transistors revolutionized the tech world. Transistors were invented at Bell Laboratories in 1947. These solid-state devices rapidly replaced the bulky vacuum tube as an electronic signal regulator. The invention of the transistor fueled the trend to miniaturize electronics. They're now considered one of the most significant developments in the history of the PC. Transistors are smaller, lighter, and consume less power than vacuum tubes. As a result, electronic systems made with them are also smaller, lighter, faster, and more efficient than ones made with vacuum tubes. Transistors are also stronger, require less power and, unlike vacuum tubes, don't require external heaters. As the size of transistors decreased, their costs fell, creating more opportunities to use them. Integrating transistors with resistors and other diodes and electronics components makes ICs smaller. This miniaturization relates to Moore's law, which states that the number of transistors in a small IC would double every 2 years. Graphic listing number of transistors on different sizes of integrated circuits. Blending transistors and diodes with resistors, capacitors, and other components produces integrated circuits. Transistors explained. A semiconductor device, which conducts electricity in a semi-enthusiastic way, falls somewhere between a real conductor like copper and an insulator such as the plastic wrapped around wires. Although most transistors are made from silicon, they also use other materials such as germanium and gallium arsenide. Silicon, a chemical element often found in sand, isn't normally a conductor of electricity. A chemical process called doping introduces impurities into a semiconductor to modulate electrical, optical, and structural properties. This enables silicon to gain free electrons that carry electric current. The silicon becomes either an N-type semiconductor where electrons flow out of it, or a P-type semiconductor where electrons flow into it. Either way, the semiconductor enables the transistor to function as a switch or amplifier. A transistor's 3-layer structure contains one of the following layers. An N-type semiconductor layer between 2 P-type layers in a positive-negative positive, PNP. Configuration. A p-type layer between two n-type layers in a negative-positive-negative, NPN, configuration. Regardless of its configuration, the inner semiconductor layer acts as the control electrode, or conductor, letting electricity enter or leave. A small change in the current or voltage at this layer produces a large, rapid change in the current passing through the entire component, enabling the transistor to function. This change occurs at the junction of both the n-type and p-type layers, also called the depletion region, which acts as an insulator. Graphic showing Microchip Technologies 8Tiny817 microcontroller. Microchip Technologies 8Tiny817 is an integrated circuit that controls specific operations in embedded systems. Microchips, which embed transistors, consist of a processor, memory, and input-output peripherals on a chip. How transistors work. A transistor operates as a switch or gate for electronic signals, opening and closing an electronic gate many times per second. It ensures the electronic circuit is on if the current is flowing and switched off if it isn't. Complex switching circuits that make up all modern networking and telecommunications systems rely on transistors. Circuits also offer high switching speeds, such as hundreds of gigahertz or more than 100 billion on and off cycles per second. Transistors are combined to form a logic gate, which compares multiple input signals to provide a different output. Computers with logic gates can make simple decisions using Boolean algebra. These techniques are the foundation of modern-day computing and computer programs. Transistors also play an important role in amplifying electronic signals. For example, in radio applications, such as FM receivers, where the received electrical signal is weak due to disturbances, amplification provides audible output. Transistors increase signal strength to provide this amplification. Parts of a transistor. A transistor is similar to a set of two diodes with their cathodes or anodes tied together. It has three terminals that carry electrical current and help make a connection to external circuits. The emitter is the transistor's negative lead. The base is the terminal that activates the transistor. The collector is the transistor's positive lead. NPN transistors have a p-type silicon base. It's sandwiched between two layers of n-type silicon, the emitter and collector. The emitter is moderately sized and heavily doped. Its primary function is to supply the electrons, known as the majority carriers, that carry most of the electrical current. It's called the emitter because it emits electrons. The base is the center terminal between the emitter and the collector. It's thin and lightly doped. Its main purpose is to pass the carriers from the emitter to the collector. The collector collects carriers sent by the emitter via the base. It's moderately doped and larger than both the emitter and base. The emitter, base, and collector have the same functions in a PNP circuit. The only difference in the PNP transistor is that the N-type base is layered between the P-type emitter and collector. The NPN versus PNP configurations determine the direction of the emitter's arrow, which is always part of the emitter base junction. The arrow points out for an NPN circuit and in for a PNP circuit. Types of transistors. There are two major types of transistors. Bipolar junction transistor, BJT. Field effect transistor, FET. A BJT is one of the most common types of transistors and can be either NPN or PNP. This means a BJT consists of three terminals, the emitter, the base, and the collector. By joining these three layers, a BJT can amplify an electrical signal and switch the current on and off. Two kinds of electrical charge, electrons and holes, create the amount of current flow. The BJT's base emitter junction is forward biased with a small emitter resistance, while the base collector junction is reverse biased with a large resistance. In a PNP-type BJT, conduction happens through holes or the absence of electrons. The collector current is slightly less than the emitter current. Changes in the latter affect the former. The base controls the base current flow from the emitter to the collector. In this case, the emitter emits holes, which the collector then collects. In an NPN type BJT, electrons pass from the emitter to the base and are collected by the collector. When this happens, conventional current flows from the collector to the emitter. The base controls the number of electrons the emitter emits. In both NPN and PNP type BJTs, amplification is possible when they operate in active region or active mode, where the base controls the flow of current between the emitter and collector. As the base current increases, the output current also increases and amplifies. An FET also has three terminals: source, drain, and gate, which are analogous to a BJT's emitter, collector and base, respectively. In the FET, the N-type and P-type silicon layers are arranged differently from those of the BJT. They are also coated with layers of metal and oxide to create the metal oxide semiconductor field effect transistor, MOSFET. In the FET, field effect refers to an effect that enables the flow of current and switches the transistor on. Electrons can't flow from the N-type source to the drain because the P-type gate between them contains holes. But attaching a positive voltage to the gate creates an electric field that enables electrons to flow from the source to the drain. This creates the field effect, which facilitates the flow of current in the FET. FETs are commonly used in low-noise amplifiers, buffer amplifiers, and analog switches. The metal semiconductor field effect transistor is often used for high-frequency applications, such as microwave circuits. Other transistor types include the following: junction field effect transistor, a three-terminal semiconductor essential in precision level, voltage operated controls in analog electronics. Thin film transistor, a type of FET often used in liquid crystal displays. Schottky transistor, which combines a transistor and a Schottky diode known for extremely fast switching to keep the transistor from saturating by diverting excessive input current. Diffusion transistor, which is a type of BJT formed by the diffusion of dopants onto a substrate. How are transistors used in power electronics? Power electronics, such as power supply units or audio amplifiers, require transistors. Their ability to switch high amounts of power on and off quickly lets them control the flow of electrical power in these devices while minimizing risks. Transistors are also useful in high-power, large-scale equipment and systems, such as electric vehicles, wind turbines, solar panels, and other renewable energy generating devices. BJTs and MOSFETs are the types of transistors used in power electronics, along with insulated gate. Bipolar transistors. IGBTs combine the strengths of BJTs and MOSFETs. They handle current the way BJT does but have the voltage control of a MOSFET. This makes them viable alternatives to BJTs and MOSFETs. How does the size of a transistor affect performance? Over time, as transistors have advanced, they have also become smaller in size, which improves their performance. There are a few reasons why the consensus among industry experts is that smaller transistors mean improved performance. They include the following: more space inside chips. When transistors are smaller, they create more space inside the microchips, housing them for more transistors and combinations to fit. This enhances computational power. Faster current switching. Smaller transistors mean less distance for electrons to travel. Shorter distances to travel mean faster current switching times. Lower power consumption. Small transistors require smaller voltages while larger ones require higher voltage. Improved processing speed. The increased number of transistors inside a chip combined with faster current switching leads to improved processing speeds. The future of transistors. Newer innovations in transistors point the way to future developments. Smaller size and increased efficiency are certainly the road to the future, as exemplified by new transistor designs. These include forksheet transistors and nanosheet structures, which are more compact and faster than current designs. Companies such as IBM are researching and testing new nanosheet innovations. There is often talk of quantum computing and how quantum computers will perform certain processing tasks faster than traditional computers relying on transistors. However, the idea that quantum computers will replace transistor-based computing on a large scale isn't likely in the foreseeable future. It's more likely that the transistor-based technology will remain important for everyday tasks while companies building quantum computers could apply them to more complex processing tasks, such as analyzing massive data sets that are too compute-intensive for traditional computers. A transistor is one of the types of semiconductor devices that is used to conduct and insulate electric current or voltages. A transistor acts as a switch and as an amplifier. Transistors are considered one of the key components in most of the electronic components that we use today. It is also considered one of the best inventions in the history of science and engineering. It is used to conduct electric current and voltage and also to insulate it. In this article, we will be talking about the transistor, its types, working, advantages and disadvantages of a transistor, and more. Table of content. What is a transistor? Types of transistors. Construction of transistor. How do transistors work? Operation of NPN transistor. Characteristics of transistor. Transistor biasing. Transistor operating conditions. Importance of transistors. Advantages of transistor. Disadvantages of transistor. Applications of transistor. What is a transistor? A transistor is a semiconductor that controls voltage or current flow in electronic signals and it amplifies and acts as a switch for them. Transistor consists of 3 layers, each of which can carry a current. If the transistor is working as an amplifier, then it transforms a small input current into a big output current. In the case of a switch, it can be one of any 2 states that are on or off to control the flow of electronic signals through an electronic device. A transistor is of 3 layers, or we can say 3 terminals, and each of them carries the current. Transistor. Transistor. Parts of a transistor. As said earlier, transistor consists of 3 layers of semiconductor materials or terminals, which helps to make a connection to any external circuit, and all the layers do carry the current. Here voltage or current applied at any one pair of the terminals controls the current or voltage through the other pair of terminals. There are 3 terminals for transistor as mentioned below. Base, to activate the transistor. Collector, positive lead of transistor. Emitter, negative lead of transistor. Basically, transistors work on the flow of current in the device from a channel to other channel. PNP transistors. Parts of transistor. Types of transistors. A transistor can be classified into various categories, however other types of transistors are there, but we are going to discuss 2 main types as mentioned below. Bipolar junction transistor. Field effect transistor. Bipolar junction transistor, BJT. This type of transistor is considered one of the most common types of transistors. BJT transistor consists of 3 terminals, that is emitter, base, and collector. It can able to amplify the electrical signal by joining all 3 layers into one. In current flow, there are 2 types of electrical charges involved, i.e. electrons and holes. The BJT can be further classified as PNP and NPN transistor. PNP transistor. In PNP configuration, the holes are the majority charge carrier. When emitter injects holes into the transistor when the emitter base junction is forward biased, these flow into base region. which controls the current passing from emitter to the collector. The base control this flow and the collector collects the holes. By reverse biasing the collector base junction, the flow is controlled, which enables modulation of the collector current by the base current. NPN transistor. In NPN configuration, electrons are the majority charge carriers. Electrons flow from emitter to collector when the emitter base junction is forward biased. The base controls this flow and the collector collects the electrons. By reverse biasing the collector base junction, the flow is controlled by regulating the collector current. BJT symbol. BJT symbol. Field effect transistor, FET. This type of transistor is a 3-terminal semiconductor device. Its operation is based on a controlled input voltage. It uses an electric field to control the field of electric current in a semiconductor. They are also known as unipolar transistors since they contain single carrier type operations. FET uses either electrons or holes as charge carriers for the operation but does not use both electrons and holes. They display high input impedance at low frequencies. There are 2 types of FET as mentioned below. JFET, junction gate FET. MOSFET, metal oxide semiconductor FET. Metal oxide semiconductor FET. Other types. The BJT and FET are the main types of transistor based on how the circuit can be used. Other than these 2, there are more types of transistors such as MOSFET, metal oxide semiconductor field effect transistor. It uses an insulated gate to control the flow of electrons. JFET, junction field effect transistor, controls current with electric field applied across a semiconductor material. IGBT, insulated gate bipolar transistor, combines features of both MOSFET and bipolar junction transistor, BJT, which is used in high-power applications. Thin film transistor, TFT, it is used in flat panel displays and sensors. HEMT, high electron mobility transistor, it is used for high-speed operation and low noise performance. ITFET, inverted T field effect transistor, it uses inverted T-shaped gate structure for improved performance. FREDFET, fast reverse epitaxial diode field effect transistor, it is used for high-speed switching applications with low reverse recovery time. Schottky transistor, it uses Schottky barrier at the base collector junction to improve switching speed. Tunnel field effect transistor, TFET, it is used for low power operation. OFET, organic field effect transistor, it is used for flexible electronics and displays. Diffusion transistor, it uses diffused semiconductor junction for amplification. Construction of transistor. A transistor is an 3-layer semiconductor device which is sandwiched between 2 same types of semiconductor. The process of sandwiching is called fabrication of transistor. Depending on the way of construction, it is of 2 types as mentioned below, PNP and NPN. 1. Construction of PNP transistor. In this type of transistor, N-type transistor is sandwiched between 2 P-type semiconductor layer as shown in the diagram. In PNP-type transistors, conduction happens through holes that carry a positive charge. In other words, it can conduct in the absence of electrons. Note that current carrying collector part is less than the emitter part and base part is the one which will control the control flow between 2 other parts. Construction of PNP transistor. PNP transistor. 2. Construction of NPN transistor. In this particular type of transistor, P-type transistor is sandwiched between 2 N-type semiconductor layers. In NPN-type transistors, conduction happens through electrons and not by holes. Note that electrons having a negative charge pass from the emitter to the base and are collected by the collector. Also, the base controls the number of electrons from the emitter. Construction of NPN transistor. NPN transistor. How do transistors work? As we know, BJT consists of 3 layers or terminals which are emitter, base, and collector. It is a device where two p-n junctions are there within a BJT. One p-n junction exists between the emitter and base region, and the second junction exists between the collector and base region. Transistors are combined to form a logic gate in which it compares multiple input current and provide output. Transistors are used in complex switching circuits which comprise all modern telecommunication systems. In the operation of BJT, the base emitter is forward biased and the base collector is reversed biased. Operation of NPN transistor. The NPN transistor is made up of N-type materials, hence the majority of charge carriers are electrons that carry negative charges. When the base emitter is forward biased, then the electrons will move from the N-type region to the P-type region, and the minority charge carriers, holes, will move to the P-type region. If they combine and meet together, they enable a current to flow across the junction. If the junction here is reverse biased, then charge carriers move away from the junction. In this case, depletion region will form between two areas and there will be no current. NPN transistor. NPN transistor. If the current flows between the base and emitter, then the electrons will move from the emitter to the base region. Note that electrons will combine if they reach the upper region. If the electrons travel without recombining with holes, then electrons will drift towards the collector. In this way, charge carriers respond and react and current flows in the collector circuit. Also read PNP transistor for further detail. Characteristics of transistor. It represents the plot or structure which represents the relation between current and voltage of a transistor in a specific configuration. The characteristics of a transistor are: input characteristics, it gives the information about the change in input current with varying voltage. Having constant output voltage. Output characteristics, it is a plot of an output current with output voltage having constant input voltage. Current transfer characteristics, this graph shows the relation between output current and input current by keeping the voltage constant. 1. Input characteristics. CB configuration, the diagram given below will describe the variation of emitter current with base emitter voltage, by keeping collector voltage as constant. CB configuration 1. CB configuration. CC configuration, the graph given below shows the variation in current in accordance with voltage by keeping collector emitter voltage as constant. CE configuration 1. CE configuration. CE configuration, it shows the variation in current in accordance with voltage by keeping collector emitter, V's, voltage as constant. CE configuration. CE configuration. 2. Output characteristic CB configuration, the graph given below exhibits the variation in emitter current, i.e., against the changes in V's by keeping IB constant. CB configuration 2. CB configuration. CC configuration, in this graph it shows the variation in IC with changes in V's by keeping IB as constant. CC configuration 2. CC configuration. CE configuration, the graph shows variation of IC with the IE by keeping VCB as constant. CE configuration 2. CE configuration. 3. Current transfer characteristics. CB configuration, this graph shows the variation of collector current IC with VCB when IE is constant. CB configuration 3. CB configuration. CC configuration, this graph shows the variation of IE with IB, when VCE is constant. VSDCC, 2. CC configuration. CE configuration, this graph shows the variation of IC with IB when VCE is constant. CE configuration 3. CE configuration. Transistor biasing. It is a process of applying a DC operating voltage condition to the transistors so that the AC input signal can be amplified correctly by the transistor. It is one of the most used semiconductor devices that is used for a wide range of applications. To obtain those functionality, a transistor must be supplied with current or voltage. It can be accomplished by various biasing circuits and techniques. Types of transistor biasing. Well, in this particular context we will see types of transistor biasing and the most common preferred methods for biasing of transistor are as mentioned below. Base resistor. The base terminal of the transistor is connected with a high value of the base resistor end. The transistor used in the circuit is of NPN type so that the other end of the resistor will be connected to the positive part of the supply. It makes the junction base emitter to be forward biased and the terminal base will be positive compared to the emitter terminal. Collector to base. In this collector to base biasing, the circuit consists of a base resistor which is fed back to the terminal collector. It is different from the method of base resistor. Note that if the current at the collector tends to increase, the voltage at the load resistor gets increased, which results in an increase in the value of the voltage at the collector emitter, and the current at the base will be reduced. Voltage divider. This type of biasing is widely preferred because it consists of two resistors. This biasing helps in providing stabilization due to the resistor present at the emitter, and one disadvantage of using this type of biasing is here the signals tend to get mixed while using this bias in the circuits. Transistor operating conditions. When a small signal is applied between one pair of terminals in a transistor, a signal can be operated to control a much larger signal at another pair of terminals. In this part, the property of the transistor is gain due to signal strength in the process of switching, and the output generated can be either voltage or current or electronic signal. If the input increases, then the output also increases. In other words, it is simple to say that output is proportional to input. Due to this particular activity, transistor can act as an amplifier. The main use of a transistor is that it makes the circuit more controllable, and the current flow is determined by other circuit elements, depending on the biasing conditions like forward or reverse. Transistors have three major modes of operations: cutoff, active, and saturation regions. Active mode. In this mode, the transistor is generally used as current amplifier. In active mode, two junctions are differently biased, which means emitter base junction is forward biased whereas collector base junction is reverse biased. In this mode, current flows between emitter and collector, and the amount of current flow in proportional to the base current. Cutoff mode. Here both collector base junction and emitter junction are reverse biased. As both the PN junction are reverse biased, there is almost no current flow except very small leakage of currents. In BJT mode it is switched off and is essentially an open circuit. This region is mainly used in switching and digital logic circuits. Saturation mode. In this particular mode of operation, both the emitter base and collector base junctions are forward biased. Here current flows freely from collector to emitter with almost zero resistance. In this mode, the transistor is fully switched on and it is a closed circuit. It is mainly used in switching and digital logic circuits. Transistor operating conditions. BJT region of operation. Importance of transistors. As we are aware, transistors are used for building simple electronic switches. They are considered as basic elements in integrated circuits. To build a microprocessor, various numbers of transistors were embedded into a single integrated circuit. Transistor is mainly used for high-power applications and low frequency, such as power supply adapters. In modern telecommunication systems, transistors act as complex switching circuits. Transistors are semiconductor devices that are used for modern electronic equipment to switch signals. It is considered a building block of modern electronic machinery which is manufactured from semiconductors. As we know, transistors consist of three terminals which are used to control the voltage and current at the two terminals. Today more transistors are found in embedded C. Advantages of transistor. Here are some advantages of a transistor. It has a low operating voltage and extremely long life. It does fast switching and has no power consumption. By using transistors, better efficiency of circuits can be developed. It is used to develop integrated circuits. It is smaller in size and lower in cost. Disadvantages of transistor. Here are some disadvantages of a transistor. If the switching frequency is high, then the transistor has greater loss of power. It generates high amount of heat and breaks down the circuit. It is sensitive to radiations, cosmic rays. It is difficult to identify the type of error and repair faulty transistors due to small in size. Transistors produce little energy, which is not sufficient for electronic signals and devices. Applications of transistor. Transistors are fundamental building blocks of modern electronics. They are essentially tiny, solid-state switches that can amplify or regulate a current or voltage. Here are some of their key applications. Switch. Transistors can function like electronic switches. By applying a small voltage, a large current flow can be controlled on or off. This capability is crucial for digital circuits, the foundation of modern computers and many other devices. Amplifier. Transistors can take a weak electrical signal and make it much stronger. This is essential for applications such as hearing aids, amplifiers for musical instruments, and radio technology. Integrated circuits. ICS transistors are miniaturized and embedded in large numbers onto tiny silicon chips to create complex integrated circuits. These ICS are the heart of modern electronics, found in everything from smartphones and computers to cars and medical devices. Memory. Transistors are used in various memory devices, such as random access memory, RAM, and flash memory, which enable electronic devices to store and retrieve data. Logic gates. Transistors can be combined to form logic gates, the basic building blocks of digital circuits. Logic gates perform basic operations like AND, OR, and NOT, which allows for complex computations within electronic devices. Conclusion. In this particular article we have seen in detail about the transistor, its types, working principle, and its application. Transistors play a vital role in this digitalized world as it helps to improve the efficiency of operational electronic signals and make more compact electronic devices and so on. So a transistor is used as a switch in the circuit. As the base voltage goes high, then current flow from collector to emitter, and then transistor gets switch on, and as the current stops flowing, then the transistor gets off. Transistors functions. Transistors have the function of amplifying and switching electrical signals. In the case of radio, the extremely weak signals transmitted through the air are magnified, amplified, before playing through speakers. This is the amplification action of a transistor. A transistor also acts as a switch, operating only when a predetermined signal arrives. An IC or LSI is a collection of transistors that provides the basic function of a transistor. Image of basic transistor function. Image of basic transistor function. Transistor as a switch. Transistor as an amplifier. Transistor mechanism. NPN and PNP transistors. History of transistors. Outline of a transistor. Transistor as a switch. Describes switching operation when the emitter is grounded. Once a voltage, approximate 0.7 V or more, is applied to the base terminal of the transistor, a small current will flow, causing the transistor to turn on and current to flow between the collector and emitter. Conversely, when the applied voltage to the base is low, less than 0.7 V, the collector and emitter are off and no current flows between them. Switching a transistor is like turning the current flow from the collector to the emitter on and off using the base as a switch. Image of switching on. Image of switching on. Transistor as an amplifier. Let's compare the function of a transistor to the mechanism of a water supply. A transistor is comprised of three legs, with the base the tap, the emitter the faucet, and collector the tank. By controlling the tap with a small force, input signal to the base, a large amount of water flows from the tank, collector, to the faucet, emitter. Using this analogy makes transistor operation easier to understand. Now, let's take a closer look at the principle of transistor amplification using Figs 1 and 2. A current, IC, HFE times the current, IB, proportional to the base emitter voltage, VBE, created by the input voltage E. And bias voltage E1 flows through the collector. This collector current IC flows through the resistor RL. And a voltage of IC x RL appears at both ends of the resistor RL. Eventually, the input voltage E is converted, amplified, into a voltage ICRL, which appears at the output. HFE, DC current gain of the transistor. Fig. 1 Fig2. Transistor mechanism. A transistor consists of a PN junction, with current flowing between the collector and emitter when current is applied to the base. Here, we will explain the operating principle using an NPN transistor as an example. When a forward voltage, VBE, is applied between the base and emitter, electrons, charge, in the emitter flow into the base, where some of them combine with holes, charge, resulting in an extremely small base current, IB. As the base, P-type semiconductor, is structurally thin, many of the electrons flowing into the base from the emitter escape to the collector. The collector-emitter voltage, VCE, induces electrons, charge, to move toward the collector electrode, generating a collector current IC. Current flows in the direction opposite to electron motion. Image of transistor operation, NPN type. Image of transistor operation, NPN type. NPN and PNP transistors. There are two main types of transistors, NPN and PNP. As you can see from the figure on the right, the difference is whether the collector terminal is drawing or delivering current in the circuit. An NPN type with emitter common is used when wanting to switch by input signals. On the other hand, it is standard to use a PNP type when using the power supply side for control. NPN type carriers are electrons, while PNP carriers are holes, charge. In the PNP type, a voltage is applied so that the emitter is positive and base negative, causing holes in the emitter to flow into the base, some of which combine with electrons in the base to form a small base current, and the rest escaping to the collector to become collector current. Resistors and transistors on single chip. NPN and PNP types. History of transistors. 1 created in 1948 at Bell Telephone Laboratories. The invention of the transistor, which has had a profound impact on the electronics industry, was first developed in 1948. This moment marked the dawn of the electronic age. Subsequent years saw rapid development of computers and other electronics technologies. Considering that this contribution has enriched all of our lives, it should come as no surprise that the three inventors, physicists W. Shockley, J. Bardeen, and W. Brattain, were awarded the Nobel Prize. I wonder if there will be any future inventions that could rival the transistor. At any rate, it is clear that the transistor has had a revolutionary impact on the modern world. 2. From germanium to silicon. Transistors were initially made of a substance, semiconductor, called germanium. However, germanium has the drawback of breaking down at around 80 C, so most of it is now silicon. Incidentally, silicon can withstand heat up to around 180 C. Outline of a transistor. Transistors are made of materials like silicon or germanium that are capable of allowing electrical current to flow through them in a controlled manner. The materials of transistors are doped, or treated, with impurities to create a structure called a PN junction. In this case, P stands for positive, and the N stands for negative. These notations refer to the type of dopant atoms, impurities, that have been added to the semiconductor material. Transistor definition. A transistor is a device that controls an electrical current by amplifying, facilitating, or stopping it. Transistors can be found in computer memory chips, cell phones, and car engines, among other applications. The most common type of transistor is the metal oxide semiconductor field effect transistor, MOSFET, which is widely used in electronic devices such as computers, smartphones, and televisions. More from this expert. What is the dielectric constant? What is a transistor? A transistor is a device that controls an electrical current by acting as an amplifier or a switch. As an amplifier, a transistor can increase the electrical output, even if the input is small. As a switch, a transistor can alternate between on and off phases to manage the electrical current. These abilities have made transistors important for everyday applications, ranging from computers to space satellites. Components of a transistor. A transistor consists of three main parts: the emitter, base, and collector. Emitter. The emitter is the top layer of the transistor that serves as the source of electrons. It's heavily doped and consists of a conductive material like copper or aluminum. Base. The base is the middle layer of the transistor that acts as the control terminal. Its lightly doped end regulates the flow of electrons from the emitter to the collector. Collector. The collector is the bottom layer of the transistor and serves as the drain, collecting electrons sent from the emitter. It's larger than the emitter and base but moderately doped. The collector is made of less conductive materials like silicon or aluminum. Transistors explained how transistors work. Video, The Engineering Mindset. How do transistors work? When a small current flows through the base, it controls the flow of a much larger current between the emitter and the collector. This is due to the fact that the base emitter junction is forward biased, allowing electrons to flow from the emitter to the base. The base collector junction is reverse biased, which means that electrons are prevented from flowing from the base to the collector. However, when a current flows through the base, it opens up the base collector junction and allows electrons to flow from the emitter to the collector. This process allows the base to control the flow of current between the emitter and collector, so we may use the transistor in a variety of ways. Transistor diagram of a transistor and its parts as described above. Typical structure of a transistor consisting of an emitter, collector, and base. Image, Shutterstock. Why do we use transistors? A transistor can act as a switch or gate for electronic signals. In practice, this means we use transistors as electronic switches that turn electronic circuits on or off. This is a basic function that we use in digital logic circuits, such as those found in computers, where we use transistors to represent the ones and zeros of binary code. We can also use transistors to control the power supply to different electronic components. The transistor acts as a switch to turn on and off the current flow. In addition, we can use transistors to adjust the voltage level, which allows for the efficient use of power in electronic devices. One of the most important uses of transistors is as an amplifier. We can use transistors to amplify weak signals, such as the output from a microphone, to levels that can drive a loudspeaker. What are the two main types of transistors? BJT. In a BJT, the base emitter junction is forward biased by a small current. This configuration allows electrons to flow from the emitter to the base. The base collector junction is reverse biased, thereby acting as a barrier to the flow of electrons. However, the forward biased base emitter junction allows a small number of electrons to flow across the base collector junction. This process creates a small current flow between the collector and emitter terminals that's controlled by the base current. FET. In an FET, the gate terminal is separated from the channel by an insulating material. Applying a voltage to the gate terminal creates an electric field that can attract or repel the free electrons in the channel. This process changes the conductivity of the channel and thus controls the flow of current between the source and drain terminals. FETs have high input impedance, which means they draw very little current from the input signal. In this way, transistors act like a switch, or an amplifier, depending on how they are connected and how much current flows through them. The input current controls the output current, which we can use to amplify or switch signals. Why are transistors important? Transistors are versatile devices that can act as switches, amplifiers, and signal regulators, enabling the processing and storage of digital information. The widespread use of transistors in electronic devices has greatly impacted our daily lives by enabling modern communication, entertainment, transportation and healthcare technologies. For example, transistors have made it possible to miniaturize electronic circuits, leading to the creation of portable devices such as smartphones, laptops, and wearable technology. It's likely that the computer revolution and the rapid advancements in electronics wouldn't have happened, as transistors are a key component in digital circuits and modern computing. This would have slowed down technological advancements in fields such as communications, entertainment, transportation and healthcare. Electronic devices would have been much larger, slower, and less efficient. Meanwhile, portable devices such as smartphones, laptops, and wearable technology wouldn't exist. Examples of transistors. Transistors are used in a variety of electronic devices and equipment. Computers. Transistors are a fundamental building block of modern computers. We use them in digital logic circuits, memory chips, and microprocessors. Cell phones. In cell phones, transistors amplify signals and control the power supply to different components. Automotive. Modern cars and trucks use transistors for engine control, power inverters for electric drives, power windows and other electronic systems. In electric vehicles, transistors control the flow of electricity in the power electronic systems, allowing for efficient conversion and distribution of power. Space and military, transistors' small size, low power consumption and high performance characteristics make them ideal for use in satellites, missiles, and other electronic systems used for defense and exploration. Robotics. Synthetic transistors are capable of simultaneously processing multiple inputs, allowing them to excel at memory-related tasks. The goal is to support advanced robotic systems that demonstrate more human-like learning. Healthcare. Transistors are used in wearable health devices to power real-time monitoring of health data. Energy. Transistors play a key role in solar charge controllers, which regulate the electrical current between the components of a solar panel system. Manufacturing. In factories, transistors can act as switches to power machinery at the appropriate times. They can also regulate LED lighting systems, contributing to workplace safety in manufacturing facilities. A transistor is a device that maintains the current or flow of voltage. It plays the role of a switch or gate switch for electron conducting signals. Transistor working has major three layers of a semiconductor substance, each has the ability to take off a current. Transistors are physically classified into two types. Those two classes are bipolar junction transistors, BJT, and field effect transistors, FET. The BJTs are once more classified into two NPN and PNP transistors. The FET transistors are more bifurcated into JFET and MOSFET. Transistor working. Transistor working. Transistor working. Usually, silicon is in use for manufacturing of transistor working system because of their extravagant voltage rating, more current and less temperature resistance. The emitter base section was known to be kept in backward biased constitutes of the physical anatomy the top current which goes on through the base region. The magnitude of the top current is very large. The top current causes the electrodes to move back into the receiver region or create a holistic region in the top region. The transistor consists of several PN diode that is attached back to back. It has 3 terminals set as emitter, base, and collector. The base is the middlemost vector-studied section which is full and made up of thin layers. The right section of the diode which is physically made of layers is called emitter diode. And the left section is a collector base diode. These names are established as per the common sections of the transistor. The emitter-based junction of the voltage unit transistor was attached to the major and to forward biased, and the collector-based junction is attached in reverse bias which offers a huge and more resistance. These names are established as per the known terminal of the transistor. The emitting end. The glowing-based junction of the transistor is connected to backwards biased, and the maker-based junction is attached in reverse order which offers more resistance. Parts of transistor. FR. In this case, the emitter base junction is attached in backwards biased and the receiver base junction is attached in reverse biased. The transistor working has to be an active region, and the collector current is independent on the glowing current. The transistor, which will be in the apparatus in this region, is made up for simple amplification. FF. In this atmosphere, both the connections are in backward biased. The transistor working is in majorly unsaturated, and the receiver current becomes dependent on the base current. The transistors act like an open switch. Both the current are in receiver biased. The glowing junction does not supply the minority charge carrying to the top, and carries the current are not collected by the collector. Thus the transistors act like a closed switch. RF. The glowing substance base junction is received in bias, collected in the top base junction, and are kept in backward biased. As the collector is loosely doped in comparison to the glowing junction and does not supply the minority charge carrier to the top, hence its current-rich transistor action is attained. Emitter. The part that provides the supply to a large section of minority charge carrying part is the emitter. The emitter always remains attached in backward biased with respect to the top so that it maintains the supply to the majority charge carrying substance of the base. The emitter-base connection follows the injection of a large amount of minority charge carrying substance into the top as it is lightly doped and normal in size. Collector. The section which does the collection of the major portion of the minority charge carrier supplied by the emitter is a collector. The collector base junction is sometimes in reverse bias. Its main function is to remove the majority charges from its connecting point with the top. The collector part and section of the transistor is moderately doped, but it is larger in size so that it can collect most of the charge carrier supplied by the emitter. Base. The middle part of the transistor with the current is the base. The base forms several circuits, the input part with the emitter and the output part with the collector. The emitter base circuit is in forwarding bias and offers the high resistance of the circuit. The collector base connection is in reverse bias and makes an offer of the lower resistance regarding the circuit. The base of the transistor working is heavily doped and very thick. Thus, it offers the majority access carrier to the top. FAQs about transistor working. 1. Quetzal. Name the 3 basic parts of transistors. ANS. The 3 basic parts of the transistors are mainly the emitter, the collector, and the base. They are the 3 basic parts of the structure of infrastructure. 2. Quetzales. Which substance is in use to make the transistors? ANS. Silicon is useful for manufacturing the transistor working system. This is because of silicon's extravagant voltage rating, more current and less temperature resistance. After having a good knowledge on the working of the diode, which is a single PN junction, let us try to connect 2 PN junctions which make a new component called transistor. A transistor is a 3 Terminal semiconductor device that regulates current or voltage flow and acts as a switch or gate for signals. Why do we need transistors? Suppose that you have a FM receiver which grabs the signal you want. The received signal will obviously be weak due to the disturbances it would face during its journey. Now if this signal is read as it is, you cannot get a fair output. Hence we need to amplify the signal. Amplification means increasing the signal strength. This is just an instance. Amplification is needed wherever the signal strength has to be increased. This is done by a transistor. A transistor also acts as a switch to choose between available options. It also regulates the incoming current and voltage of the signals. Constructional details of a transistor. The transistor is a 3-terminal solid-state device which is formed by connecting 2 diodes back to back. Hence it has got 2 p-n junctions. 3 terminals are drawn out of the 3 semiconductor materials present in it. This type of connection offers 2 types of transistors. They are PNP and NPN. Which means an N-type material between 2 types and the other is a P-type material between 2 N types respectively. The construction of transistors is as shown in the following figure, which explains the idea discussed above. Construction of transistor. The 3 terminals drawn from the transistor indicate emitter, base, and collector terminals. They have their functionality as discussed below. Emitter. The left-hand side of the above shown structure can be understood as emitter. This has a moderate size and is heavily doped, as its main function is to supply a number of majority carriers, i.e. either electrons or holes. As this emits electrons, it is called as an emitter. This is simply indicated with the letter E. Base. The middle material in the above figure is the base. This is thin and lightly doped. Its main function is to pass the majority carriers from the emitter to the collector. This is indicated by the letter B. Collector. The right side material in the above figure can be understood as a collector. Its name implies its function of collecting the carriers. This is a bit larger in size than emitter and base. It is moderately doped. This is indicated by the letter C. The symbols of PNP and NPN transistors are as shown below. Symbols of transistors. The arrowhead in the above figures indicated the emitter of a transistor. As the collector of a transistor has to dissipate much greater power, it is made large. Due to the specific functions of emitter and collector, they are not interchangeable. Hence the terminals are always to be kept in mind while using a transistor. In a practical transistor, there is a notch present near the emitter lead for identification. The PNP and NPN transistors can be differentiated using a multimeter. The following figure shows how different practical transistors look like. Practical transistors. We have so far discussed the constructional details of a transistor, but to understand the operation of a transistor, first we need to know about the biasing. Ezoic transistor biasing. As we know that a transistor is a combination of 2 diodes, we have 2 junctions here. As one junction is between the emitter and base, that is called as emitter-base junction, and likewise, the other is collector-base junction. Biasing is controlling the operation of the circuit by providing power supply. The function of both the PN junctions is controlled by providing bias to the circuit through some DC supply. The figure below shows how a transistor is biased. Transistors biasing. By having a look at the above figure, it is understood that the N-type material is provided negative supply and P-type material is given positive supply to make the circuit forward bias. The N-type material is provided positive supply and P-type material is given negative supply to make the circuit reverse bias. By applying the power, the emitter-base junction is always forward biased as the emitter resistance is very small. The collector-base junction is reverse biased and its resistance is a bit higher. A small forward bias is sufficient at the emitter junction, whereas a high reverse bias has to be applied at the collector junction. The direction of current indicated in the circuits above, also called as the conventional current, is the movement of hole current, which is opposite to the electron current. Explore our latest online courses and learn new skills at your own pace. Enroll and become a certified expert to boost your career. Operation PNP transistor. The operation of a PNP transistor can be explained by having a look at the following figure, in which emitter base junction is forward biased and collector base junction is reverse biased. PNP operation. The voltage V provides a positive potential at the emitter which repels the holes in the p-type material. And these holes cross the emitter base junction, to reach the base region. There a very low percent of holes recombine with free electrons of N region. This provides very low current, which constitutes the base current IB. The remaining holes cross the collector base junction, to constitute collector current IC, which is the hole current. As a hole reaches the collector terminal, an electron from the battery negative terminal fills the space in the collector. This flow slowly increases and the electron minority current flows through the emitter, where each electron entering the positive terminal of V, is replaced by a hole by moving towards the emitter junction. This constitutes emitter current IE. Hence we can understand that the conduction in a PNP transistor takes place through holes. The collector current is slightly less than the emitter current. The increase or decrease in the emitter current affects the collector current. Ezoic operation NPN transistor. The operation of an NPN transistor can be explained by having a look at the following figure, in which emitter base junction is forward biased and collector base junction is reverse biased. NPN operation. The voltage V provides a negative potential at the emitter which repels the electrons in the N-type material, and these electrons cross the emitter base junction, to reach the base region. There a very low percent of electrons recombine with free holes of P region. This provides very low current, which constitutes the base current IB. The remaining holes cross the collector base junction, to constitute the collector current IC. As an electron reaches out of the collector terminal, and enters the positive terminal of the battery, an electron from the negative terminal of the battery V enters the emitter region. This flows slowly increases and the electron current flows through the transistor. Hence we can understand that the conduction in a NPN transistor takes place through electrons. The collector current is higher than the emitter current. The increase or decrease in the emitter current affects the collector current. Advantages. There are many advantages of a transistor, such as high voltage gain. Lower supply voltage is sufficient. Most suitable for low power applications. Smaller and lighter in weight. Mechanically stronger than vacuum tubes. No external heating required like vacuum tubes. Very suitable to integrate with resistors and diodes to produce ICs. There are few disadvantages, such as they cannot be used for high power applications due to lower power dissipation. They have lower input impedance and they are temperature dependent. But 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 impedance and they are temperature